Okay, so now in this section I will explain you how we're gonna solve these problems. Okay, so the problem, what values of the angular momentum, that means L, and magnetic momentum ML are allowed for a principal quantum number n equals 3, and how many orbitals are there in this energy level? So we are given the principal quantum number 3, meaning n equals 3, and we want to find out the L values and ML values. So let's see how we're going to do this one. So we are given n equals 3, and you need to find out the L value and ML value. So how do we find the L? L is going to be the values 0 to n minus 1. Now, if n equals 3, what are the possible L values? Obviously, 0 would be there. What is n minus 1? N equals 3. 3 minus 1 is 2, right? So, it goes from 0 to 2. 0, 1 and 2 are going to be the L values. Okay? And then what are the ML values? ML values could be minus L to plus L. Right? So if L equals 0, what are the possible ML values? It could be only 0. And then if L equals 1, ML going to be minus 1 to plus 1, minus 1, 0, plus 1. Remember, when you are going from minus 1 to plus 1, it has to go through 0. So 0 is also included. And the ML values, if L equals 2, going to be minus 2, minus 1, 0, plus 1 and plus 2. So those are the possible L and ML values for the principal quantum number 3. So how many orbitals this represent? Remember, these L numbers represent the shapes of the orbital. So if L equals 0, what is that orbital going to be? That is your S orbital. Okay, if L equals 1, that's P. If L equals 2, that is a D orbital. Now, this ML values tells us number of orbitals. So, if ML equals 0, meaning it has only one orbital. That's 1 right there. And then there are 3 ML values for L equals 1, 1, 2, 3. So that represent there are 3 orbitals. And then here you have minus 2, minus 1, 0, plus 1, plus 2. There are 5 orbitals of D. So 1 plus 3 plus 5 is 9 orbitals possible. Okay. So if you look at the solution, for n equals 3, allowed values for L are 0, 1, 2. And for L equals 0, ML value 0. For L equals 1, ML minus 1, 0 plus 1. For L equals 2, goes from minus 2 to plus 2. So there are 9 ML values. Therefore, 9 orbitals with n equals 3. Okay. Next one. Give the name, magnetic quantum numbers and number of orbitals for each sublevel with the following quantum numbers. You have n equals 3, L equals 2. Always remember that the L values, when L equals 0, 1, 2, 3. Remember this. When the L values are 0, 1, 2, 3, the specific orbitals are going to be S, P, D, F. Okay. So the first one, n equals 3, L equals 2. So you need to give the name of the orbital. Since the principal quantum number is 3 and L equals 2. And when L equals 2, that's going to be a D orbital. So that's going to be 3D orbital. And then what are the possible ML values? If L equals 2, possible ML values are going to be minus 2 to plus 2. And then since there are 5 ML values, number of orbitals are going to be 5. Okay. And then the second one, n equals 2, L equals 0. When n equals 2, that's the principal quantum number. When L equals 0, so when L equals 0, that tells you that is an s orbital. So the sublevel is going to be 2s. Okay? And then the possible ml values are going to be based on the L value. Minus L to plus L, it has only one value, which is 0. And the number of orbitals is going to be 1. And the third one, n equals 5, L equals 1. So when L equals 1, that talk about the p orbital. And n equals 5, so that is a 5p orbital. Possible ml values, you get the ml values from based on the L values. Minus L to plus L, so minus 1, 0, plus 1. So the number of orbitals possible going to be 3. 1, 2, 3. Okay. Last one, n equals 4, L equals 3. L equals 3. Remember, L equals 3 is talking about a f orbital. Since n equals 4, that's going to be a 4f orbital. Possible ml values. ml values come from the value L. Minus 3 to plus 3. So there are 7 orientations possible, meaning there are 7 number of orbitals for the f orbitals. For the f shape, there are 7 number of orbitals. Okay. Next one. What is wrong with each of the following quantum numbers, designations and or sublevel names? First one, we are given n equals 1, L equals 1, ml 0, name 1p. So what's wrong in this combination? When n equals 1, what are the possible L values? L can go from 0 to n minus 1. N equals 1, so 1 minus 1, 0. So L cannot be 1, correct? L has to be 0. So what's wrong here is L cannot be 1. Can ML be 0? Yes, ML can be 0. What should be the name going to be? Is it going to be 1p? No, it cannot be 1p because there's no p in the first level. You know that, only s available. And this L has to be 0. So in that case, L has to be 0 here. So this is going to be 1s orbital instead of 1p. So 1 is wrong in that one. And also it cannot be 1p, it has to be 1s. Okay. And then the next one. Next one, you have n equals 4, L equals 3. If n equals 4, can L be 3? Yes, because it can go from 0 to n minus 1, which is 0 to 3. So this is correct. And can ML be plus 1 if L equals 3? Yes, because it can take the form from plus 3 to minus 3 to plus 3. So plus 1 included in it. So you can have plus 1. So the name of the orbital going to be 4D. Is that correct? 4D. 4 is correct. How about D? Remember, we talk about L values 0, 1, 2, 3. So they represent S, P, D, F. If it is a D orbital, then L has to be 2. But here you have L3. So this is wrong. So what's the correct designation going to be? Since L equals 3, it has to be 4F instead of 4D. Okay. And then the last one, L equals 1, N equals 3, L equals 1. Is that possible? Yes, N equals 3, L equals 1 is possible. How about ML? Can ML be minus 2 if L equals 1? No, it cannot be negative 2. How about being 3P? So 3 is correct. Is P correct? L equals 1. So then the 3P is correct, right? So that's correct. So what's wrong in the C is you cannot have minus 2 as ml. Okay, so that's what's wrong in that one. Any questions? So go over these problems again so you'll be able to understand more. All right. So now we talk about that you can have s orbitals pretty much in all kinds of energy levels. So we're gonna designate them as 1s, 2s, 3s. As the principal quantum number increases, the size of the orbital also increases. If this is 1s, it's smaller in size, and then the 2s become a little bit bigger, and then the 3s become even more bigger than that 1s, 2s, 3s, like that. Okay, so this shows us the cross section of the 3 orbitals. So remember, s orbital is spherical in shape, and this is a 2p orbital. So p orbital is different from the s orbital. It takes the shape of a dumbbell. Okay, like this, a dumbbell. So the first one is a cross section of electron cloud, and the second one accurate probability contour, and then the third one is a stylized one, this one over here. Okay, so how many p orbitals are possible? There are 3 p orbitals possible, remember, because it has 3 ml values. So what are the possible 3 values? You can have minus 1, 0, plus 1. Remember, we talk about there are 3 possible ml values. So those are the 3 orientations. So it can be along the px axis, py axis, or pz. So it could be this is your minus 1, this is your 0, and this is your plus 1 orientation. So 3 p orbitals, they would be perpendicular to each other, and then it would look something like this, perpendicular to each other. You can see bunch of balloons together, but they are along the x, y, and z axis. So this is your x axis, and this is going to be your y axis, and this is going to be your z axis. 3 p orbitals. Okay, and then if you look at the d orbitals, d orbital look like a butterfly, and then L value for the d orbital is 2. L value, remember, and then it can go from minus 2 to plus 2. There are 5 d orientations: minus 2, minus 1, 0, plus 1, plus 2. So they are these orientations. So you can consider this as your minus 2 orientation, minus 1, 0, plus 1, plus 2. So there are 5 d orbitals. Okay. First 4 would be like butterflies. They would align along the axis labeled here, and then the last one is different. You can see it's like a I don't know what it looked like. Anyway, you guys know it looked like this. Okay, and then the 5d orbitals put together, you can see them all like this. You see, like that, 5d orbitals. And then the next one is f orbitals, and for the f orbital, L value is 3. So minus 3 to plus 3, there are 7 possible f orbitals. And what you are seeing right now is just one p orbital. So there's going to be 7 p orbitals like that. So those are the shapes of the 4 orbitals. And these orbitals are located in the nucleus, not in the nucleus, but extending from the nucleus, but they're going to be based on the energy levels. So 1s would be the lowest in energy excuse me, And then you have the 2s and 2p in the second energy level, and then you have 3s, 3p, 3d in the third energy level. And when the electrons are being filled, they fill the same order. 1s would fill first, and then goes to the 2s and 2p, then the 3s, 3p, 3d. So we're going to learn about that part in the chapter 8. Okay, so this concludes chapter 7, and then we are ready to do our second exam once we are done with this one. Okay, all right, then I will conclude this section here. I will talk to you later again with chapter 8. Bye for now.